So last time we started by making the seconds 0 to 9 alarm system, and we started by making a CD4017 for the set alarm. So this for the set alarm, and we needed another CD4017 which is going to come from the clock, and both of them are going to come. They are going to go to the time matcher, which will be AND gate, and if both of them are true, then it's going to trigger the siren module. So we have a CD4017 right here, which is the one that we built last time, and we see that it has two buttons: the set, which when once pressed is going to drive the output from the previous one to the next one to the next one to the next one until the one that you want. And right next here we have a reset, if you want to reset everything and start all over again when you make maybe a mistake. Yes. So today we have two circuits right here. We have the one for CD4017 that we did last time, and we have a new circuit right here which is having a CD4029. So I want to explain why I've decided to go to stop using a CD4017, which is this one right here, and jump to CD4029 because of the following reasons. So this is a CD4029. The reason as to why I'm preferring this one, because I'm preferring this one than the CD4017 is because if for a CD4017, let's say we want to display the seconds from 0 all the way to 9. So what do we need? We need two CD4017s, for the one for set that you're setting and the one from the clock. Yes, and we'll need, for the time matcher, we'll need an AND gates, which is going to be 10 AND gates to check every single bit, every single value, 10 AND gates. All of these are going to come if you want even to compare the zero outputs, we are going to require inverters, which are not gates, which are going to yes, inverters. Right here we also need an OR gates, which are going to be a 10 input OR gate, which is going to check the values from the AND gates, and if any of them is true, then it's going to give an output to the siren module. So checking at the CD4017, and this one is going to come in every single bit. So for the seconds, it's going to require all of these logic gates. For the tens of seconds, it go from 0 all the way to 5. It's going to require maybe less than this one, because this is going to 10. And for the minutes, 0 to 9, it's going to require the same ones as for seconds: 10 AND gates, 10 input AND gates, or 10 AND gates, 10 input OR gate, and maybe inverters. Now let's go to CD4029. For the CD4029, it displays in binary, and it's in 4-bit binary, 4-bit binary. So the advantage of using a 4-bit binary number, because 4-bit binary can display from 0 all the way to 15, but we're only interested from 0 all the way to 9. So this one is quite advantageous, because using a less output, meaning that we are going to require less logic gates, because using only 4-bit binary to display from 0 all the way to 9 will mean we're going to require only 4 pin or 4 input XNOR gate to compare. This is the time matcher to compare the values that we have from the user and that one for the clock. And we're going to require 4 input AND gate that's going to check all the outputs from the XNOR gate and decide if all of them are on, then it's going to give an output. So this is more accurate. It's very small in terms of connection, and it's quite very simple. So that's why I'm going to use a CD4029 rather than using a CD4017. And this kind of circuitry is significant when you want to display big time. Let's say you want to display maybe 8 minutes and 42 seconds. For the CD4029, you're going to use a very significantly less amount of logic gates as compared to the CD4017, because for the CD4017 you have to check every single bit from 0 all the way to 9, but for the 4029 it only checks in binary. So if you just use 4-bit binary to display from 0 all the way to 9, it means that you can do a lot of things with and you can do a lot of things with the IC, and it's quite simple as compared to the other integrated circuit. So that's why you're going to use a CD4029 29 rather than using a CD4017. And just to display, let me just show you how it counts in binary. If you want to connect these or make one of these circuits, you can just use the schematics that we have in all data sheets, app or website, and you can just make it simple like that. So this is how it counts in binary, and it counts all the way from 0 all the way to 15. So that's why I'm preferring using this one rather than using a CD4017. So yeah, so thank you very much guys for watching. Please subscribe to Tronics Energy. If you have any questions or suggestions, leave them down in the comment section and I'll be glad to answer you guys. So yeah, so thank you and hope to see you next time. Goodbye.